Hello, so it's Michael here, and today I thought I'd do another tutorial, but this time I thought I'd do something a little bit different to what I've done so far. So at the moment I'm currently in one of my personal projects that I've been working on, and the tutorial I'm going to be doing today is something that I've used in this particular project itself. So it's sort of around the concept of fixed cameras. So this is where instead of having the character follow the player, the camera itself either stays in a fixed location or moves along a track, essentially. So what I'm just going to go ahead and just sort of play. As the character moves, the camera kind of follows where the character is in terms of where it's looking. But as the character moves around, the camera itself moves along a track. So at this particular point, I'm not controlling the camera in any way. It's all done based on where the character is in the world, and it sort of moves the camera along a track to a certain position. As a part of the system, it also has a system of allowing you to move two different tracks. So here is a sort of different track that it's following. So as it enters it, it sort of moves around like so. So it's quite a flexible system that allows you to sort of control how things are and that type of thing, and it sort of frees up in a sense a control in terms of the cameras that the player no longer has to worry about. So this can be sort of perfect for certain types of games where you might not want them to be able to see absolutely everything and give them that sort of control. So yeah, so without further ado, what I'm going to do is open up a new blank project using the third person template, and we'll start with the tutorial. So back in a second. Okay, so here we are. So I'm just in a blank third person project. So there's nothing in here additional. So it is as it is. You play and you run around. Okay, so the first thing I want to go ahead and do is, I guess, create the initial blueprint. So I'm just going to come to the content browser and I'm just going to create a new folder. I'm just going to call this one blueprints. And this is just to put the things in. And then inside there, I'm just going to create another new one. I'm just going to call this one camera track. So, and then in there, we're going to go ahead and create a new blueprint class, and it wants to be of type actor. I'm going to call this BP camera track, like so. And once you've done that, you go ahead and open it up. So now that we're in here, we want to go ahead and add a few components in here that we'll use for the camera track itself. So start by adding two spline components. So the first spline component I'm going to go ahead and call path. I'll sort of explain what these are in a second. And then for the second spline, I'm going to call this the camera track. So, in terms of these themselves, you just want to make sure that they're attached to the root and not each other, like so. And then lastly, on the camera track itself, that's where we want to add a camera. I'm just going to add a normal camera like so. So the camera itself is attached to the camera track, but both the splines, so the camera track and the path, they're just attached to the default scene root. And the reason we attach them to the default scene root is just so we can actually move these around independently in the scene. So with that done, I'm going to go ahead and actually just drop that in the level so you can sort of see what it looks like. So the reason why we have the path and the camera track separate and not, well, sorry, the reason we have the path and the camera track attached to the scene root is so we can move them independently within the component itself. So the camera, as that would normally be attached to the camera track anyway, obviously we just attach that accordingly. So with the way this is set up already, you can come in, click on the points on the spline, and you can move them around, rotate the points to sort of make the curve. And whilst you're in the movement mode for the gizmo, if you hold left Alt and drag, that can create a new point, like so. So you can move that around, and as you can see, it's sort of bending the curve based on the actions. Alternatively, with the spline mesh selected, there are additional controls in here as well that are part of Unreal in terms of selecting the different spline points and manipulating that way if you wanted to. Okay, so I'm just going to go ahead and delete these ones for now. So the reason we have both a path and a camera track is because we don't necessarily want the camera's position, or where the camera is positioned on the camera track, to be based on how close the player is to that specific track. Instead, what we use is the path. So whenever the camera is going to move, it's going to be based on where the character is in relation to this path itself. And then that information will be used to position the camera along the camera track. So this can sort of allow you to have quite a long path, but then a short camera track itself, and so it kind of makes the camera move a lot slower along the track if you have a really long path. Or alternatively, you can have a really small path and then a really long camera track, and that would cause the camera to move quite quickly along that particular section. So the ultimate goal with this is that you'll be able to have multiple camera tracks to denote different areas within the scene that will control what camera is being used and things like that. Okay, so with that done, let's jump back into the actual blueprint itself, and we can start looking at setting some of the things up that we'll need. So the first thing I'm going to do is inside the camera track itself, I'm just going to just delete those nodes from the event graph, and then I'm going to go ahead and create a new function. And this particular function is going to be called set cam owner, like so. So go ahead and open up the function. And what this is going to need is an input. So add a new input. I'm going to call this one character. So this is the character that now owns this particular camera component, as it were, the camera track. For the type, I'm just going to go ahead and choose the third person character. Depending on what you're doing, you might be able to get away with just using it as sort of your own type if you've got your own projects. So go ahead and choose that, and it wants to be the object reference. From the input on the function node, if you drag from the character input, and we just want to promote that to a variable, and I'm just going to call that cam owner. So that should automatically create it as the type of third person character. So the next thing I want to do is check to see if this is actually valid or not. So what this is going to do, it's essentially going to be using this to enable and disable this particular blueprint. And by disable, I mean set whether or not this particular actor is ticking or not. So what we can do is, if it's valid, we can set actor tick enabled, and once that's true. And if it's not valid, we want to disable that. So the reason we're doing this is because when we get to the part where we're going to be switching cameras, we will effectively set the owner of the blueprint camera track, and if it doesn't have an owner, then nothing's going to be using it, so therefore it disables the tick. Okay, so that's the starting point there. So the next thing we want to do is create a new function called update camera. Like so. And this is going to need an input of type vector. I'm going to go ahead and call that world location. So with that done, if you go back to the set cam owner, you can then drop that function in, and we want to call that function if the cam owner is valid. So this is when it's initially set, it's going to update the camera to essentially where it should be. Okay, so there's a few ways that you can do this. I'm going to get a reference to the cam owner. Now, if you wanted to, you could just get the actor location, like so, and just connect that in if you wanted. However, from my own testing, I've found that specifying a bone on the actual mesh itself tends to yield slightly nicer results, particularly if you've got some animations that might come out of the bound slightly. So what I'm going to do instead is pull from here and get a reference to mesh, like so. And then I'm going to use the get socket location, like so. And I'm going to connect that in instead. Now for the actual socket name, I'm going to use spine underscore 04. Now just for context, if I open up the skeletal mesh for this, so I remember where it is. So I believe it's the SK mannequin. So if we look on the skeleton here, I'm using the spine 04. So it's going to sort of always be using this particular location to determine information regarding the camera. Normally if this is in a blueprint, it tends to be about halfway down, so it'll be a little bit lower if you're just using the act location. Alternatively, you can use any part of the body if you're using the sort of socket method. You might get nice results if you use just the head, depending on what sort of thing you're doing, that sort of thing. But obviously that's up to you whether or not you want to go down that particular route or not. Okay, so with that connected up, we need to then start setting up some of the things inside the update camera function. So if we go ahead and open that back up. So inside of here, what we want to be doing is setting the desired location and rotation for the camera. So for us to do that, I'm going to go ahead and create two new variables. I'm going to call the first one desired location. Usually helps if I spell that correctly. There we go. So desired location, that's going to be a type vector. And then the second one is desired rotation. And that's going to be of type rotator, like so. And we are wanting to set these, so we can just drag these in and set them like so. And then we can connect it up. Okay, so the first thing I'm going to do is actually just set the desired location, just because that's a little bit more contained within here. So for this, we want to essentially get the rotation from the camera to the player character. So if we drag a reference to the camera in, and we want to get the world location, and then we can use the find look at rotation node. So this, you provide it with two locations in the world, so the start and the target, and it will provide you with the rotation that would be required to be able to look at the target from the start location. So the start in this instance is the camera, and then for the target that's going to be the cam owner. So if we drag a reference to that in, and for this you can use the get actor location again. Alternatively, if you wanted to, similar to how we do on the set cam owner, you could use a socket if you wanted to. Again, using something like the head might be something that you want to do, or possibly a bit lower or higher, depending on the sort of camera angles you might be using. I'm just going to use it as the get actor location for now. Right, so that's the rotation of the camera sort of setup, so that's going to get that for us. Now the next thing we want to do is get the location from the camera track that the camera needs to be positioned at. So if we get a reference to the camera track and we pull from there, we want to use the node get location at time. Now this node itself will essentially get the world location along a point on the spline. So as you can see, so between the various points, if you've got multiple points, it'll just get the actual world, the location, depending on how you set it up. So on this particular node itself, you do want to make sure that the coordinate space we're using is world. And then you've got a choice here in terms of use constant velocity or whether or not you want to have it a bit more smoothed out in terms of the location. It's up to you. You can play with that particular setting if you wanted to. So I'm going to connect that like so. Now, the next thing we need to do is actually get the time. So the way that the time works on the spline, so if I just select one for you, you'll notice that here there's a duration, which is in seconds. So I could add as many pointers as I want to, but the duration itself will always stay at whatever it's set in here. Now, for what we're doing, we don't necessarily need to change the duration. That's not going to be an issue, but we still need to get a point along that duration. So if we leave it at 1 second, you kind of think of it as percentage along the spline. So at 0.5, that should be around halfway to the spline. Now the thing is, we want to do that based on where the player is to the path. So if we go back to the BP for the camera track, now to do this, what we're going to do is actually create a function that's going to get that time that we need. So for this, I'm going to go ahead and create a new variable, and I'm going to call this, a new function, and I'm going to call this get time along spline at nearby location. Bit of a lengthy name there. So for this, it's going to need an input. So this is going to be world location, and then we also want another input. Of this one's going to be a type float, and I'm going to call this one distance lag. Now, one of the issues that we're going to face, which is the reason why we have the distance lag input there, is there could very well be times where, if say the cameras, well, let's say the path and the camera track are the same, exactly the same length. So you could sort of run into an issue where the player is right in the middle and then the camera is literally going to stay on top of them, which isn't going to be particularly nice. So we kind of want the camera to be lagging behind based on where they are. So that's what the distance lag is going to be for. So in terms of getting the location from a spline, based on the location, it's not the most straightforward. But let's go ahead and get this sorted. So I want to start by dragging in the path. And what we want to use is, if we pull from that, we want to do find input key closest to world location. So this is kind of where we're going to get been able to use that world location to get what we want. So if we drag from that and just type in world location, you want to use the input variable, so it should have a little green pill shape next to it. Sorry, the yellow pill shape. That's so. And just in case you're wondering, I am using the Q shortcut key to straighten up the lines. Okay, and then once we've done that, we want to get another reference to the path. And this time we want to do get distance along spline at spline input key. So this itself is getting the input key based on the world location we provided, and then we're going to use that to get the distance along the spline. And once we've done that, we want to get another reference to the path, and this time I want to use get time at distance along spline. So as you can see, it's a bit of a chain, but essentially we're using the world location to get the input key closest to it along the path spline, then use that to get the distance along the spline, and then we use the distance to get the actual time that we need. Now, if we just move the get time at distance along spline over slightly, and what we actually want to do is we want to minus or subtract the distance lag from it. So we get that variable. You want to make sure it's the one with the green pill, so that'll be the input here. You can just connect it like that if you want to. So with this particular node here, this is where we're getting the distance along the spline, and because we want it to be offset slightly for the actual camera track, that's where we add the subtract the distance lag, so it'll bring it back a little bit. Like so. Now if we add a return node to the function, and we'll just connect that up, like so. And we'll just drag from that return node and pop it out, and that'll get us the green return node that we need on there. Now, there is another section to this, which I will go with shortly, once I'm in a position to actually show you what one of the problems are. However, if we come back to the update camera, and we can drag this particular node in, so they get time along spline. At the moment it's a standard function, but what we want to do is just create it as a pure function. So if you go back into the get time along spline node by location, select the first node, and in the details panel just put a tick in the pure, and then compile and save. And when you go to the update camera, it should create it like this without the execution pins. And then we can go ahead and connect that into time, like so. Now for the world location, we'll just connect that from the input on the update camera function. And then for the distance lag, I'm just going to create, just drag from there and do promote to variable. I'm going to call this one movement lag offset. Like so. Now this particular variable is going to be defaulted at 0, and that's perfectly fine for now. We will go through and sort that out shortly. Okay, so at this particular point, the update camera function is complete. So what we can do now is, obviously in the set cam owner, that's already set up there. So if we go to the event graph and we want to add a on tick node, so event tick. And what we can do is if we get the cam owner and we right click on it, convert to a validated get. So what we want to do is check to see whether or not this camera owner actually has an actor or not. So that's the same as just doing is valid. Yeah, so these two are the same. It just sort of combines the nodes together. So on the event tick, if we just connect that together, and then we want to go ahead and do the update camera again. So is valid, I want to do that. And I'm going to do the same thing as in here, where we get the socket location, like so, and just connect that to the world location. Again, if you're choosing just to use the act location or something different, you can just update that here as well. Okay, so at this particular moment in time, we are getting close to actually be able to test it. So what I'm going to do, so we'll sort out the interp functions to actually interp the camera's location and rotation to those locations. So if we go ahead and create a new function, this one's going to be called interp location. And what we can do is we can drag in the desired location, and we want to check to see if the camera's world location matches the desired location. So if we pull from the camera, we do get world location, like so. And then we want to do an equal. Like so, and then a branch. So if it is equal, actually I'm just going to set the tolerance there to 1. Doesn't have to be exactly perfect. You can probably have a play around with this, but I found with 1 it's perfectly fine. The reason I don't like leaving it at 0 is just because you can end up with some really small 0.0001 movements which aren't really that necessary in the grand scheme of things. So it kind of just stops it from constantly updating the camera when it's not really needed. But you can have a play around with that to see what works best for yourselves. Now, if it's not equal to the desired location, we actually want to set the camera location. So if we set world location on the camera, world location, there we go, on the false. And what we want to do is actually interpolate from its current position to that desired location. So pull from new location, we do v-interp, so that's vector interpolation. And the current input, so that's the current location that you're trying to interpolate. So in this case, that's going to be the location of the camera. And then the target is going to be the desired location, so you can bring that variable in there. For the delta, that's going to be delta world seconds. So delta world seconds is delta that's been adjusted by time dilation, so this can be quite useful. So if you are using time dilation, using this particular one it means the time dilation will affect updating the camera image as well. And then lastly, it's the interp speed. So this is how quickly it's going to move from its current location to the desired location. So I'm just going to pull from the interp speed and promote that to a variable, and I'm just going to call this movement like speed. If you just save and compile, you can then set the default value. Personally, I'm just going to go ahead and set that to 2. You can set it as instance editable as well. And that'll just mean that when you select the main blueprint, it'll give you as a variable you can change. So you could technically set it at different speeds depending on the actual camera track that's being used. Okay, so I believe that's that one done. Just tidy these nodes up a little bit. Okay, there we go. So that's the interp location. Now we need to interpolate the camera as well. So I'm going to create the function for that. So go ahead again and create a new function. This one's going to be called interp rotation. And it's going to be set up very similar to the one we've just done with the location. So go ahead and get the desired rotation. We want to do an equal. And again, so get the reference to the camera and want to get the world rotation. That's so. Now when it comes to the equals on this particular node, rotations are from 0 to 360 generally, or minus 180 to 180, but obviously there is a range there. So small point, like 0.01 for example, can be quite a big difference. So for the tolerance, I am actually going to set a value of 0.01. Again, you can have a play around with this to see what's best, but for me, I found that seems pretty good. So from there, you want to go ahead and use a branch. Again, if the camera rotation matches the desired location within the tolerance, we don't want it to do anything, so we leave that how it is. If it's not, however, we want to set the camera's rotation. So bring the camera in again, and we want to do set world rotation, like so. And we can get that to the false. And from the new rotation on the set world rotation node, we want to go ahead and do the r-interp. So again, this is very similar to the one we use for the rotation. It's just using the rotator instead of the vector. So again, the current is the current world rotation. So the target is the desired rotation. And delta time again, so delta seconds. And then for the interp speed, I'm going to put that to a variable again, and this time I'm going to call that one rotation like speed. So it gives you sort of two options, well, two control points for controlling the speed in which it interpolates. So I'm going to set it as instance editable again. I'm going to set that to a value of 2 as well. Again, you can play around with these to get the desired effect that you're looking for. Okay, so I'll quickly tidy these up again. Okay, so that's those nodes completed. So if we go back to the event graph where the event tick is, we actually just want to go and add these into the chain so these get called. Now I know some of you might not like using tick, but normally with things like moving the camera, potentially the location of the player character, you normally need to do those on tick anyway just to make sure that it's nice and smooth. So don't worry too much about the fact that this is on tick. So with these added in, we are nearly at a point where we can actually test the sort of the core basics of this. However, before it works, oops, just got a crash.